Next examples that we have, we're going to look at actually polar equations and show how can we convert them into rectangular equations and then vice versa. So first what I thought we'd do is let's look at a polar equation. What does that look like on the graph? Let me show this. First we have to put our calculator in polar mode. So I go to the mode button right here, and the fourth one down, POL, stands for polar. Now when you hit the y equals, notice you've got r's equals. Instead of y's, you can have r's. Hit -3 sine theta. The theta is just where the x normally was. I'm going to go ahead and hit zoom 6, zoom standard, and we get a graph. And we get the graph of a circle. Okay, well, we have studied circles before. We have equations of circles in rectangular coordinate axes. So how can we turn this polar equation into a rectangular equation of a familiar looking circle? Okay, well, there's a few techniques involved based on how the problem starts. With this particular type of problem, r equals this -3 sine theta, so we have an r equals and it's equal to sine or cosine. Typically what I do is I multiply the whole equation by r to start. Would result in r squared equals -3r sine theta. And now we're going to use some conversion formulas that we had previously been using with points. R squared is equal to x squared plus y squared. R sine theta is equal to y. If we bring this over, we get x squared plus y squared plus 3y equals 0. That is a general form equation of a circle, and we can leave it just like that. Next example is kind of similar to the previous example, but it's not set up r equals, so I could get it to an r equals form if we divide by the secant theta. And we all should know that that is the same as, dividing by secant is the same as multiplying by cosine. So we get here, and now we're going to do the same thing that we did in the last particular problem. We're going to take this whole thing times r. If I do that, we get r squared equals 3r cosine theta. The r squared and the r cosine theta have substitutions for each of them. R squared, we just saw on the last slide, is equal to x squared plus y squared. R cosine theta is equal to just x. And if I bring that over, x squared plus y squared minus 3x equals 0. If you graphed it up here, you find that it's another equation of a circle. Next couple examples I want to do is how can we convert from rectangular to polar. Let's begin with substitutions for x and y. X is equal to r cosine theta. Y is equal to r sine theta. Notice now there is an r that is a common factor. If we take that out, we get r times the quantity 2 cosine theta minus 3 sine theta equals 5. Dividing by all that in the parentheses gives r equals 5 divided by 2 cosine theta minus 3 sine theta. That is our polar equation done. I know it's done because I've gotten it to r equals. In this next example requires a little bit of algebra before we can do some substitution. Let's begin this problem by squaring this binomial. Y minus 1 squared is equal to y squared minus 2y plus 1 equals 1, which is then x squared plus y squared minus 2y equals 0, as the 1's can be subtracted away. Now we've got a couple of substitutions to make. X squared plus y squared is equal to r squared, minus 2, and then the y is equal to r sine theta. We can pull out a common factor r, leaving behind the quantity r minus 2 sine theta. And if we solve this, we get r equals 0. This one solved gives r equals 2 sine theta. I want this one over here that is an actual equation. This one, r equals 0, is just kind of simply a point. We're just going to kind of throw it away. This is the piece that we want. This is the equation that is equivalent to this equation of the circle up above. In this last example, a little application, the location given in polar coordinates of two planes approaching Vicksburg Airport. So let's see, we've got 12 degrees 4 miles, so 12 degrees 4 miles, maybe that's about here. And 2 miles 72 degrees, that's maybe about here. Okay, what I want to know is the distance between the airplanes. We're trying to find this distance, called x. Okay. Well, so what do I know so far? What I know is that this distance is 4, this distance is 2. If I find the difference between these angles, I'd find that this angle is 60 degrees. We have a way to find x using law of cosines. Whenever we have a side angle side, it would say that x squared is equal to 2 squared plus 4 squared minus 2 times 4 cosine of the angle between them. That would give x squared equals, let me type all this in, check the mode, we want degree mode. So let's see, I've got 2 squared plus 4 squared minus 2 times 4 cosine 60. So that's equal to 12. And so the square root of 12, or x equals 2 square root of 3, units are in miles.